Ladies and gentlemen, my name is Mojto, and today I would like to introduce to you the presentation about the data treatment of industrial measurements from online to inferential sensors. This work is done in a cooperation with Slovnaft oil refinery in Bratislava. So we have a plant with several online sensors providing frequent measurements of desired variables, and we indicate the composition of the plant product through infrequent lab analysis. The measurements from online sensor must undergo online data treatment procedure where systematic errors and outliers are indicated and removed from the measurements. Retained data is subsequently stored in the refinery database with the rest of the historical plant data. With the historical data, it is possible to design or update an inferential or so-called soft sensor, which is then capable to infer the desired product composition from the measurements of the online sensors. And this inferred variable can be, for example, used to monitor the state of the process. In this research, we focus on the central part of this scheme where the online data treatment takes place. We studied the following data treatment methods: Hoteling's t-square distance, minimum covariance determinant, and k-means clustering. The first two techniques indicates outliers according to the mean and covariance metrics of an analyzed dataset. The k-means clustering considers more centers with several different data clusters. The number of clusters and the clusters that are considered as containing outliers are determined according to the heuristic tuning. We use the presented methods to indicate outliers within the measured data on two real industrial units. The retained data is used for the inferential sensor design using currently used structure of the inferential sensor at the plant, PCA, and lasso. The results from this research indicate that the tuning of t-square distance and k-means clustering is a challenging problem. The first reason is that the t-square distance seems to be quite noise sensitive because this method considers more than 60% of the data from VGH for outliers. The second reason is that the k-means clustering is very sensitive with respect to the choice of the number of clusters, and therefore it is an issue to find a suitable criterion for the detection of clusters with outliers. Our result suggests that the MCD method has a good performance in both case studies with a low effort of tuning. The overall improvement of the current inferential sensor in both case studies is around 15%. So dear colleagues, this is all from my side. Thank you for your attention, and please consider contacting me via an email for your questions or comments. Have a nice day.